Okay. In section 3.1, did we ever write the word derivative?
No.
Yes.
No.
One. And we said it's something really important in this. Then did I say the word derivative at all again?
No.
Nope. Nope. What did I say? I said tangent. I said average. I said secant. I said instantaneous, but I did not say derivative. That was on purpose. We were talking about the idea in 3.1. We're going to define him in 3.2. What is the slope of a tangent line? What is the slope of the graph at a point? What is the instantaneous rate? What are all of those ideas combined into as a term? The derivative. Some of you have seen this in physics. Some of you have seen this or heard this last year in pre-calculus when we talked about it briefly at the end of chapter 12. Some of you have heard me say this multiple times but without much context. So now, tons of context. We just came from 3.1, how we were talking about, it would be helpful to know the instantaneous rate, to be able to find the slope of a tangent with only 1 point, to find the slope at an instant. And all of that description is what is summed up in the term derivative. Okay? Sorry. I'm not giving enough time. A couple of you were still back. Let's get more in depth. Definition of the derivative. Now, hold on. Wait. Well, what was this important box back here? A verbal description. It's a good description. It's an important description. We're going to have to refer back to him over and over, which is why I decided to take a whole day on 3.1. Usually I just kind of skip over it. But the description is important. But the definition, because you guys know math people, right? Don't they like shortcuts?
Yeah.
They can't just stop at that nasty limit formula and say done. And they're not going to, but they do have to start with, we have to start with the foundation. Which is why when my physics people were like, why don't we know derivatives yet? Because we need to build up to it. And we did a lot of that in 3.1. Today is a lot of recapping, applying it to this new word derivative, looking at him and all of his different forms as verbs and adjectives and all, as different nouns. So we have a new word in math. So we're going to talk more about him. But first of all, we have to define him. We have to start at the foundation. So we've talked about the idea, slope of tangent, instantaneous rate. You guys like another form of this, and in just a second I will say it's okay to use him, but I am going to go ahead and use the actual definition, which is the limit of the slopes of secant lines as the removed x approaches the point of tangency, or as the change in x approaches 0, is going to be the slope of the tangent line, the instantaneous rate, the derivative of a function f. And what notation do you see at the very beginning?
F prime.
F prime of x. Just like f inverse of x, this little notation next to the name of the function, not on the outside, just like inverse, if it's in here, it's notation for something. And the little apostrophe, we can't tell, it's a little apostrophe. We're going to say it as f prime of x. Stands for, is notation for the derivative. We're going to talk more about that in the next page. So the derivative of a function f, the idea, slope of the tangent line, instantaneous rate, is found by our limit of the difference quotient from really last year. You guys talked about difference quotient quite a few times. They just kept telling you it's important in calculus somehow, and yeah, it's actually the foundation because it's the slope formula, and as I have 2 points that are removed, approach 1 point of tangency, taking a limit, which is also super important. I find my derivative. Now, my English people, I know there's a little typo. Did you find it? There's like an awkward for all. Sorry, split sentence. I did a weird run-on thing. I don't know what I was doing. So the derivative is given by provided the limit exists. For all x for which the limit exists, f prime is a function of x. But this also kind of begs the question, so f prime doesn't always exist? Yeah, we'll talk about that. I'll wait some more. Easier notation. This is the one that a lot of you guys I just heard like a whole lot better, and I'm going to say yes, that's okay to memorize instead. The limit as h approaches 0. As long as you identify h is delta x. If you identify that at the very beginning, I will say yes, this is a fine alternative form of the definition. So if you don't like that one, you can predominantly memorize this one. Memorize. However, what I just said is that if you don't like change of x, you can use the easier notation instead. You can choose which one you want to put in there. I'm not going to judge based on what you put. You have free will. You have option, the choice.
5.
Thank you.
When you say identify it, does that mean you have to write it down?
Yep. Well, like on a forever quiz. If you were to use this one, I just need h equals change in x. Cool. And then you can use this, like you can state this with a definition. You can use this to actually solve for derivatives, etc. So I don't mind if you're using it as long as, just like the other people that are memorizing this one, you know what h is. Okay? But technically, he's an old formula because we practiced him in chapter 2 on the practice test. We practiced him on WCC. We looked at him on Friday. Let's go to something new. If we have a new word, which we do, relatively new. I know some of you guys have heard it before and have used it before, but hopefully you have a better foundation as to what it means now. He also has some different forms. So, derivative terms. Derivative is a noun. Slope of a tangent line, slope at a point, instantaneous rate. It's a noun. What do these sound like? Even in the English language. They're related and they're not nouns, they are verbs. There, my grammarians, thank you. So if it has to do with derivatives, and if it's a verb, it probably means something to the effect of
Doing it.
You're defining doing it. Doing what? Taking the
act of.
The act of. Act of is a noun, isn't it? Kenny, what's up?
I think he's locked out.
I think
He's high-fiving me.
He's not locked out. He's fine.
Are you okay, Kenny?
Guys, shh. To take the derivative of, right? Like in different languages, you're talking about Spanish, all the different root forms of the verbs. To eat, to run, to.
Are they synonymous?
They're not synonymous with Spanish vocab. I'm sure there is a Spanish word for derivative. I'm not sure. Okay.
No, I mean like, is derive and differentiate synonymous?
Yes, derive and differentiate are synonymous. They mean the same thing. It just depends on who you're talking to. Now, guys, there is a dilemma that comes with, derive and differentiate means to take the derivative. Aren't those just regular words in English as well? And you might have heard, like, math teachers, probably me as well, saying something like, let's derive this formula from, but did I really mean deriving in the mathematical sense? No. Or let's differentiate between, well, no, that's the English use, the English definition, the English word, right? As opposed to the now calculus defined. Differentiate means take the derivative of. Derive means take the derivative of. Synonymous. Notation. Here's the most common one. For the verb itself. If you see d dx, which we're going to talk about more about that notation in a little bit. You guys watched the video with Leibniz and Newton, right? And Leibniz had this supposedly really spiffy notation. That's it. So to take d dx of something means to derive, to differentiate, to take the derivative of. We'll talk more about that later. Differentiation. This sounds an awful lot like a noun, right? And Jezreel, this is what I would say is the act of. Like the act itself, not the action. Not the actual playing out of the action, but the act itself. Differentiation is the whole process of finding the derivative. The act of, or the process of taking the derivative. But now we have another way of saying that. So let's say of deriving. Differentiating. How about that? We'll make it sound differentiating. I know it's silly, we're going through vocab, but I don't want you to be confused when I'm saying something like, let's derive this, or you're like, what am I don't get it. Okay, you're driving me crazy. Okay, come back. Failed sweatshirt attempts. Okay, so differentiable, what does that mean?
It's the adjective.
Adjective, differentiable. I know my OCD ones, I'm sorry, there's an underline. Differentiable is a function able to be derived but maybe a little bit more clarification on that. Whose derivative exists. Because as we know in math, derivatives or numbers or things we're solving for sometimes do not exist. Okay, kiddos, we are going to go ahead, as you saw on the backboard, if you looked, we're going to go ahead and continue on 3-2 tomorrow, and we're doing lots of examples. Lots of examples, okay? So come tomorrow ready to practice, practice, practice. Tonight, you can start homework, but it's not due till Wednesday, so some of us have a little bit of a break to get questions answered, etc. Bye, guys. I won't be here during lunch, but I'll be here after school. Thank you.